like to introduce Tiberio Caetano from the Gradient Institute to give the first talk of the day.
So I will briefly start with some general framing around the event, and then I'll go into the first component of the introduction that we are going to see this morning. There will be 3 talks this morning, early this morning, before our break for morning tea. There'll be 3 introductory talks, as Liam alluded to. So I'm giving the first one, which is a snapshot on the state of AI. Then we're going to have talks by Daniel Murphy on technical AI safety and Kimberly Weatherall on AI governance. So before morning tea, it's a little bit of an introductory setup framing for the event. As Liam alluded to, AI safety is gaining significant momentum internationally. We've had the Bletchley Declaration last year. We've had earlier this year in May the Seoul Declaration, where there was a statement of intent about collaboration internationally on AI safety science. There was also the formation of AI safety institutes in the United States, in the United Kingdom, also in Japan, Singapore, and others are emerging. There has been the formation of a network of state-backed AI safety institutes that are sort of starting to form this general collaboration around efforts in science and governance in this space. And there are a list of countries, of which Australia, importantly, is a member, who is a part of this emerging network of institutes. Very importantly, and specifically for this event, there has been a launch this year, early this year, at the Seoul Summit in May, of the Interim International Scientific Report on the Safety of Advanced AI. This event is really foundational for the future of AI safety, in our view. And that's because it's an attempt to bring together experts from all over the world, from a wide range of fields, to start developing some sort of shared understanding about the capabilities of AI, the risks of AI, and how to go about managing those risks. So this event is very strongly framed around that report, as we'll see soon. So here's the report. Professor Yoshua Bengio, a very well-known leader in the field of AI for many, many years, Turing Award winner, has been the chair of this effort. And there has been around 90 contributors to this effort. So scientists, researchers, experts in AI from a wide variety of sources of expertise. Very importantly then, the mission of this report is to drive a shared science-based, up-to-date understanding of the safety of advanced AI and continue to develop that understanding over time. So the premise here is that policy action in this space must be grounded on the best scientific understanding that we have. So we need to work together to form, establish, consolidate that scientific understanding as a first step. A few things about the report, and then soon I'll actually get started on the proper state of AI. This report has many specific things I would like to call out. First is a work of independent experts. Second, it deliberately focuses on general purpose AI, as Liam referred to earlier. Third, it really is delineating and sort of categorizing these 3 different areas: capabilities, what AI can do; risks, what may go wrong; and how to go about managing those risks. Because the report is a scientific report, and only a scientific report, it is still quite technical only in the risk management component. Of course, a lot of what Kim will be talking about today will be how do we go much beyond just the technical to a more socio-technical, broader conversation around risk management. Another really important thing about this report is that it really makes a genuine effort at highlighting the areas in which there is expert consensus and areas in which there is not so much expert consensus and areas in which there is very little expert consensus. This is a fundamental thing about science. The calibration of our beliefs, the calibration of our understanding about what constitutes a good proxy for the truth is fundamental. And I think this report made a really good effort in that direction. Also, and crucially, the report makes it very clear that the stakes here are very high. We will see throughout the day and tomorrow as well a lot that will be speaking to this particular important point. And back to the uncertainty aspect, the fact that we don't know everything, the report also recognizes there's a wide range of possibilities of how AI may unfold in the future. It doesn't attempt to put probabilities on anything. It's doing a really good job in terms of being reasonably sensible about being cautious. And this is another great merit of this report. It recognizes that this is a major policy challenge, which almost follows directly from the things we've been discussing up to this point. And finally, as Leon so clearly put it at the beginning, AI doesn't happen to us. We decide what's going to happen with us. And AI is part of that. So it will depend on the future of AI will depend on our collective decision making. And I'm so thrilled that now in Australia, we are starting to create this community around AI safety and try to channel our vision, try to channel our efforts, our competence, our will, our souls into this very important challenge. So just finally on the report, and just reminding the key things I alluded to previously, the report is asking three fundamental questions. The first question is, what can general purpose AI do? We have some understanding about that. We don't know everything about that. We'll talk about capabilities. I'll refer to that soon. We know quite a bit about that, but there's a lot of things we don't know as well. Second, what are the risks associated with general purpose AI? Again, we can enumerate a wide variety of concerns that many different experts have delineated, have enumerated about what may go wrong with AI. But again, there is uncertainty. We don't know how things will materialize exactly. For certain things, we know more than for other things. It's really important to try to make this genuine effort to be careful about assessing how much we actually know about each of these hypothetical or not so hypothetical risks. And finally, the report makes an effort to assess what is out there at the moment in terms of technical tools, methods to attempt to control and manage those risks. As I mentioned before, this is a scientific report. It doesn't go into policy. Its purpose is to report on the state of the science, to support efforts like what we are about to start developing here today in Australia, of thinking about policy, thinking about risk management more broadly, thinking about governance. It's a starting point for establishing the facts insofar as we understand them to be facts, establishing the science, and on top of that, trying to build a consensus about how to respond to these facts. And last slide before I actually get into the AI. Before morning tea, we have these 3 introductory presentations. Please write on Flux any questions associated with these particular introductory presentations this morning, because we are going throughout the day to be able to address them. And specifically during the panel discussion, we are going to have an opportunity to leverage those questions, address them, and also discuss the themes that sort of emerge, the topics that emerge from these questions. So let's start a bit with the state of AI today. So this was AI in 2014, 2018, 2022, and this is AI this year. So if you look at this, you may think, all right, that seems like a significant type of development in just 10 years. And you may also ask the question, is that a fluke? Is that an accident? Have I just deliberately picked the right kind of images to put in here so that everyone can believe that AI has progressed so much over 10 years? Well, it turns out that the sentiment expressed by this slide turns out to be well supported by science. A little bit of additional general information here about the progress of of AI over the past 10 years, or in this case here goes even a little bit back on that. Test scores on humans versus AI performance. Look, this is not a perfect measure of what we call intelligence. We don't even know what intelligence is, even though there's one guy in this room who thinks he does, and he'll talk about it later in the day. Hello, Marcus. But the fact here is that there are many different ways for you to assess, or to try to assess, what constitutes progress in terms of cognitive capabilities, or progress in terms of accomplishing tasks that would otherwise have been capable of being accomplished only by humans on the cognitive domain. But the fact is that there is growing amount of evidence that this is real. And you can see here examples for a wide variety of categories of tasks, from code generation, predicted reasoning, image recognition, and then there is this question around reasoning. It's very interesting conversation out there about whether AIs actually can reason, whether these large language models are actually reasoning. We think that that's a very interesting conversation and can be quite refined as well from a scientific viewpoint, and interesting answers may pop up as one refines that question. Now let's get a little bit more into more quantitative information to give us a sense of what's actually going on in the world of AI. And for that, I would like to call out 3 facts. So the first fact is that we have observed an acceleration in the resources that are put into building AI systems. So this graph here shows you, since around 1950, the amount of computational power, basically the amount of flops, used to train what would at the time be considered the state-of-the-art sort of machine learning system. Okay? And then you can see an interesting phenomenon. You can see that sort of in the first 50, 60 years of AI, so to speak, we've got a certain rate of advancement. In the past 10 or 15 years, something changed. And that has been a very fundamental fact, because it seems like suddenly we almost like are living through several decades in just one decade from the point of view of computational power. It turns out that this type of observation also translates to other resources like data. And you can identify more and more the amount of data that's being used to train AIs is also growing exponentially, especially in the past decade or so. Naturally, I'm sure you're all aware of the fact that big players in AI, like Google, like Microsoft, and so on, Amazon, they are taking AI really seriously. You can look at that from the point of view of, we need to go nuclear, okay? And there are other ideas about how to get more energy to be able to run all of these data centers that are being proliferating and growing by the day. If you really thought that this was going to be a trend in, let's say, 2022, and you really believe that AI specialized chips would be the future, and as a result of that, you put a lot of money into this company here, then you are in a pretty good financial situation today. So clearly, this acceleration in the resources to build AI is real. Here are a few more data points showing that we've seen this in compute, in data, the costs, of course, running the systems. You need to buy more GPUs. You need more energy. Also, algorithmic improvements. This is often not paid attention to too much. We've seen all this scaling in terms of resources that indeed, that we're going to see in a minute, really do make the systems quote unquote smarter, but it's also true that there's also a rate of improvement in how much intelligence, so to speak, we can get out of every flop, of every unit of compute power. Now there's a second fact. And I still, every day I wake up, I think about this second fact. Because I've been working in AI for 25 years, in the science of AI for 25 years. 1989 was when I started. And when I look back in this 25 years and I ask myself, okay, what is the one thing that you just didn't see coming? If you had to rank those things that you really didn't see coming, I would put this fact number 2 as the top in my list. And what this fact is basically saying is that these resources that we've alluded to before, if you put more compute, if you put more data, they actually translate into what we call capabilities. They not only make your AI system faster, more efficient, which is a traditional thing you get out of putting more resources into it. You just throw more money into it, and out of it, you get IQ points. You can buy your way into intelligence. Now, this is a profound scientific reality. And it's not only a profound scientific reality, but has profound consequences as per this gathering here today. This is a key ingredient responsible for us being here today. We call this scaling laws. And these are empirical observations that as you increase the compute and dataset sizes and parameter sizes of these models, here we have some graphs showing the test loss, which basically tells you, how much you make mistakes in your predictions. And this also translates into what we call capabilities. So these plots here show you in the horizontal axis basically more and more resources being put into the building of these models. And the vertical axis, what you see is that at some point you start to see significant increases in the cognitive performance of these models as a result of more compute put into it. And similar things happen for more data put into it. We're not refining the algorithms. We're not bringing new PhD students to create new ideas to generate these AI improvements. We are just throwing more money into the problem. Okay? I can't overemphasize how profound this is. So let's then just sample a little bit of what scaling laws mean. Here's a video showing a certain amount of compute, and there is a query saying something about, I don't know exactly what the query is, but it goes from amount, well, you can gather from what you see. So this is the base amount of compute, okay? So a bit more, just for you to appreciate the, yeah. All right, yeah, okay. Okay, let's increase the compute by a factor of 4. Okay, let's go again. This looks better. Note, our intervention here is increasing the amount of compute only. Now let's do it 32 times. In this particular case, we kept the amount of data fixed. We kept the architecture of the system fixed. We kept everything fixed. We are just throwing more compute into it. You can buy compute. NVIDIA is making money, and you're getting that. All right. So here's a quote from the report. If these recent trends, if they continue, those straight lines that I showed before, AI developers will be training models using from 40 to 100 times more compute than in 2023, the most intensive compute models we had then, by the end of 2026. Okay, so basically, from 23 to 26, we may be pushing ahead in terms of 2 orders of magnitude in terms of amount of the compute. And if you just project this out, if these trends continue, it will be a factor of 10,000 by 2030. So I want you now to just go back to this, think about this 10,000 factor by 2030. I want you to think about that, and then I want you to think about this one, right? Where we had here this, and for a 32 factor, we had that. I don't know exactly how these will translate. No one knows. But if these trends continue, then we will be able to train models with 10 times more compute in 6 years than we did last year. Recently, we've seen more and more recognition of the fact that these trends, there is a real possibility that they continue. There's a lot of debate about whether they will continue, the extent to which they will if they do, and experts disagree vastly on that. But here's an example of a statement from the White House saying that the foundational drivers that have underpinned recent AI progress show little sign of abating. I would just add that, yeah, that may be true, but there is a lot of uncertainty. But this is kind of a precautionary note. There's a third fact. Well, the third fact is that if, on the one hand, resources like compute and data are almost like sufficient to actually make AI smarter, they are definitely not sufficient for making AI safe. Ideas are needed to make AI safe. And I think I don't need to go too much into this. We will talk about risks throughout this event. But for the people in this room, if you are in this room, you've seen, no doubt, many instances of the harms that are already being reported around AI and many concerns about potential future harms that may materialize. Now, I really want you to reflect on these three facts together. Fact number one, just like AI is accelerating very fast. Fact number two, it's not accelerating fast because there are millions and billions of researchers working on it. It's accelerating very fast because money buys it. We can just throw more money into it, and you get smarter AIs. But then fact number three tells us that if you throw more money at it, yes, you get more intelligent AIs, more capable AIs and all that, but there's one thing you don't get out of it. You don't get safety. Now I want you to put those three facts together, and this is the state of AI in 2024. So clearly, we have a problem. So my job in this first introductory presentation here is to show that there is a problem. Then soon we'll tell a bit more about the technical challenges and what we can do about it. Kim soon will talk about what we can do in the system. Say again?
The tortoise wins in the end.
Well, in the Aesop's fable, it does. That's a hope for sure. I'll get back to that. So now, just before we wrap up, let's go briefly into how the scientific report that we are sort of framing this event around discusses risks. I think there are many ways you can cut this cake. The way the report has chosen to categorize these risks has been into these three broad groups: malicious use, risks from malfunctions, and systemic risks. All of these risks are legitimate concerns that the report goes in detail into and raises the fact that, hey, these are legitimate concerns substantiated by scientific evidence. And there is no thing we do have in physics. I'm a physicist, so I like to think about principles of conservation of energy, principles of conservation of momentum. Conservation ideas are very important in physics. There is no principle of conservation of risk. So if someone is concerned about one type of risk, and that's the really pet risk they're concerned about, it's fine, but remember, that doesn't make any other risks less likely to also be legitimate and also to materialize. So I think this report does a good job at recognizing there's a wide range of risks. But if we look from a risk management perspective, we also must recognize that the stakes of different types of risks are not equal. The extent to which these stakes are not equal is naturally up for debate, but we must recognize that they won't, by a rule of God, to be made equally important. And we, as people making choices about the future of our society, of our technology, need to remember that. We need to make trade-offs because we have finite resources, even if all the risks are legitimate. So perhaps now, at the end of this first introductory session, let's remind ourselves of a very fundamental principle in risk management. So the precautionary principle, it's a really elementary idea. I hate the name, the precautionary principle, because if you tell someone this is the precautionary principle, that word is a bit sophisticated. And the principle, you can explain to a 10-year-old or maybe a 5-year-old. It basically said, look, if you don't know what's going on, just don't assume that everything is going to go well. How hard is that idea? Okay? That is what the precautionary principle is. And in light of the vast uncertainties that we have, in vast of disagreements about what may or may not happen, in addition to, in light of the evidence that we have a hare and we have a tortoise, we must act now. And that's why this event is happening here now. All right. So Dan, I'm back to you now. So this is the final slide, but clearly, Dan sort of stole my punchline. but the point here is that the hare is not sleeping. The hare doesn't stop in the middle of the run and go and sleep under a tree, for those who are familiar with Aesop's fable or tale. So this is the challenge. We need to beat this hare, but the hare, if things continue the way they are going, it's not like the hare halfway through is going to stop and have a nap under a tree. That doesn't look like it's going to happen. So the challenge is, how do we get this turtle, this tortoise, never know the difference, but to actually be ahead of this hare? And look, I think there are many people out there who think this problem is very hard to solve. Some think it's very maybe unsolvable. Others think the problem doesn't exist, that the hare somewhat has, some sort of Ferrari on top of a Ferrari and so on and so forth, which may also be true. But the fact of the matter here is that we need to make sure that we don't progress with highly capable AI into the future without ensuring that humanity is protected. And with that, I'm going to close my initial introduction. The next one is going to be by Dan Murphy on technical AI safety. Thank you very much.